So I know I've uncovered everything. We're going to focus on knowing active as everything moving against the concentration gradient from low to high, okay? And then even though I'm going to give you 3 slides of active, you're only responsible for knowing the minimum information of each, like how the molecules move, and the answers from low to high, and if they move in, it would be endocytosis, okay? So the movement in against the natural flow is endocytosis. The movement out, okay, against the concentration gradient, which means from what to what?
Can you go back for like 1 second?
Answer the question. The movement out against the concentration gradient means what? From what to what? Nope. Low to high. High to low is what kind of transport? Passive. These are active. So the concentration gradient or the normal path is always high to low. If you're going against that path, what do you need to make it happen? Nope. Sometimes. What do we say you need?
Water?
Nope. Energy. Active transport requires energy, and the molecules move from low to high. For this test, again, focus on these terms right here. We'll worry about this later when we get more into actually seeing this happen. And same here. We're focusing on exiting out of the cell from low to high, okay? And the last one, the last type of active is called the sodium-potassium pump. In this case, you're going to move sodium or potassium. It's very specific. In and out of the cell through the protein from low to high. So you're going to underline these key words. Proteins move sodium and potassium in or out from low to high, which means from what to what? Give me another way to reference low to high. Nope. It is a type of active. Give me other words that describe low to high. The movement from low to high is also known as less to more. Now the K's are potassium and the greens are sodium. All right? And I know this is referencing a sodium-potassium pump. Then we've got these red molecules that are everything else. And I'm going to go ahead and draw like maybe a couple right here. Others, right? And I'm going to add some here. All right, now, if I draw this, and this is something you guys are going to do in your animations. If I draw this right here, I took the red molecule and I went in that direction. What type of transport is that? Who can answer? So we went low to high, and if I say this is the in, and this is the out, what type of transport is that? What type? It's a type of active, and it's going out of the cell, exocytosis. Okay? That's one example. We went from where there's less to where there's more outside the cell, so it's exocytosis. Now, if I do it backwards, I'm going to do this. What type of transport is that? Look at it carefully, look at your notes, and then give me an answer. In which direction are the molecules moving? Answer that first. They're moving in. Where else are they moving? Yes. They're not. There's more outside than there is in. There's 1, 2, 3, 4, 5, 6, 7, 8 red dots on the outside, and there's only 3 on the inside. It's going from more to less. Through what? Through the phospholipids. What's it called? Diffusion. Yeah, get ready. This is what I've been warning you about. All right, now I'm going to do another one. Let's say I do this. Which direction are the molecules moving? In. High to low. When you move from high to low, what type of transport is that? Passive. What type of passive transport? Facilitated diffusion. How do you know it's facilitated diffusion? Because molecules are going through the protein from high to low. Okay? I'm going to give you another one. What if I do this? This K here is potassium. If I go like this, what did I just do? I went in from low to high, which is a type of what transport? Active. And this perfect example of what? It would be, except it's a sodium molecule, so it's a type of endo, and I would give you credit for that because it's going into the cell from low to high. And more specific, if it was sodium and potassium moving at the same time, it would be a sodium-potassium pump. But we're not even going to worry about sodium-potassium pump on the test at all. We're going to worry about endo and exo as the type of active, okay? All right, so forget this word. Let's say even pretend they don't exist, and the rest are just molecules. One more example, and then we're done. If I do this, I'm going to take the green, and I'm going to go right here. What did I do? Raise your hand if you could tell me. I'm going to give you all the questions, and these are the questions you're going to ask yourself. In which direction did the molecules move? Out. What else did they move? From high to low. When molecules move from high to low, what type of transport is that? Passive. When molecules move from high to low through what is that? The lipid layer. It's called?
No, just diffusion.
Diffusion. End of story. Okay? Now one more. Remember what I said yesterday about water? Wherever there's less solute, right? So I'm going to erase these. Wherever there's less solute, whoops, I didn't want to erase that. There's more what? Wherever there's less solute, there's more of what? You wrote that in your notes yesterday. Where there's less solute, there's more what? There's more water. So where is there more water? In or outside of the cell? Out, because there's less solute on the outside, yes? So in which direction is water going to move? Who could tell me? Raise your hand. In which direction does water always move? High to low. In which direction is water going to move? High to low is where in this diagram? In. There's more water here, so it's going to move here. Water moves in.